database commands. What you're doing is you are sending commands to a database to get data really quickly. So SQL language is only useful for running database commands. It is not, you would never use it to write a program. You would never use it to make a application. It's just for interacting with databases. However, the SQL command interface, the SQL language itself is powerful for what it is. And so you can try running some SQL commands in this box here. Now, in a real website, you would never have this. You would never let users run whatever SQL query they want. That would be disastrous on a level you would never do that. So if you were to run some commands here like show databases, this command is pretty self-explanatory. We're going to look at all the databases on the server. So we run this query, submit, and now we see we have two databases, information schema and widgets. Awesome. And by the way, if something happens to this database, you can click this button here, and it will reset the database. And there we go. We have everything's back to normal. So if we were to, for example, drop, let me look up the drop command. Drop table command. Drop table name. Okay. So if we were to run drop table widgets, unknown table widgets. Oh, that's right. Hold on. Show tables. So widgets.employees. So if we were to drop table widgets.employees, oops. Drop table widgets.employees. That is going to go away into the either. Oh, something went wrong. Okay, never mind. The point is you can mess up the database, and you can just click here to reset it. And you can run all these commands. So normally what you're doing with the SQL command on a website is you are gathering data from the database using something called a select statement. And you can run some select statements here, like select one. So what this is going to do is it's just going to return the number 1. There we go. Select 1. We get 1 back. That's great. That's not very useful. You can return a string. So we can return peanut. Cool. Oops. If we run peanut, okay, we got a string back. Awesome. Here's where we start to get interesting. So we can run something called concat. And this is useful in SQL injection, because what we can do is we can put 2 values together into a single line in a table, which will make sense later on. I just want to point this out because it is really important with SQL injection, because you have to return the same number of tables as the original statement when you start doing injection. So this concat statement is going to be useful later on. So now we have, okay, there we go, peanut butter. So we put peanut and butter together to make peanut butter. Awesome. So let's do an actual query from the database. Select star from employees. What that's going to do is going to select all the data from the employees table. So we run that command. There we go. So this is all the data from the employees table. So we have an ID, a name, and a social security number. And you can, everything is just being done from that database. Now, usually when you're running SQL queries, you don't want to grab everything unless you're a terrible app developer who thinks it's a great idea to download everything from the database and send it to your phone, which I've seen. You usually want to just grab a few things from the database. So let's do, let's just grab the IDs from the database. And now we just have the IDs, 1, 2, and 3. Perfect. And usually that's not what you want either, because sometimes you can have databases with millions and millions of things in it, right? You don't want to download millions of items and have to go through it manually. So what you will do is you will create a SQL command with a where statement. So a where statement looks at the table and will select only the lines, only the only the rows in that table where the where clause is true. I can't speak. So if you have a where clause like this, like select name ID, select name and ID from the employee tables where ID equals 1. What's going to happen is you are going to select these two items, the name and ID, from the employees table, but only where the ID is 1. So this would select, I think Bill Gates had ID of 1, so this will only select Bill Gates. Yep. So we returned the name and ID from the employees table where the ID is 1. Awesome. And that's how you'd normally use a SQL database when grabbing data from the server. Is another one I want to do. We can do the insert command. As I mentioned, you can change values in this database. So if we want to insert items into the database, this is how you would do it. You would, oh, no, that does not work. Is it because of the semicolon? No, something's going on, Sam. But that is the correct statement you would use. You would insert into the employees table these 3 items with the values of 4, Kevin, and the social security number. And I do want to point out the last thing we want to look at is just regular SQL queries is the information schema table. Every time you create a new MySQL instance, the software creates this database or table called information schema. Information schema contains metadata about the database, including, if you scroll down to the bottom here, which is a long way down. Oh, maybe not. See if we can find it widget. There we go. So you can find things here in the information schema about how the database is made up. So we can see here that there's a table called widgets, a table schema called widgets, and a table name called employees. So there's a widgets.employees here, which we saw earlier. And a lot of times, looking through the information schema is how you're going to get information about the database that you will use to do the SQL injection. So, okay, what does SQL injection look like? So when programmers create SQL queries like this in their code, if you're using a very old method or you don't know better, what you'll do is you'll create a string that looks like this. Select star from, let's say, employees. You'll want to run a command like this. And so what the programmer will do is they'll make a string that says select star from, and then add the table name afterwards. And so what we can do is we can take advantage of that, just like we did with the Linux command with the ping command. But instead of sending bash commands, we're going to be adding SQL commands to the end of the template. So here we have a search form for names. And this is a common thing to do with databases, is to search through it. So we'll search for Bill Gates. We'll see if Bill Gates is in the database. And as we already knew, Bill Gates is in the database. Awesome. Let's look for Tip O'Neill. Those of you who may be young enough to remember that, an old politician. We're going to look for Tip O'Neill in the database, and let's see what happens. Oh, we got an error. Why did we get an error? Well, let's look at, luckily because this is for exercises, we can look at this series, we can look at the query that got sent to the server. So it says here, select name from employees where name equals Tip O'Neill. But notice that Tip O'Neill is in single quotes. And if we added, and the O'Neill, the single quote in O'Neill, ends this quote here. So what the SQL server reads is, select name from employees where name equals Tip O, and then there's this Neil at the end for no reason in this command, and it gets really confused, doesn't know what's going on. That's because it's treating this part right here as the SQL command itself. So what was supposed to be a name in quotes is now part of the SQL command. So if we were to take advantage of that, we could say, for example, add a comment afterwards, which would just get rid of the rest of the command, and it would run fine. It would say, select name from employees where name equals Tip O, And then this does not get executed because this is a comment. The pound sign right here means the rest of this command is a comment. Awesome. So what we can do with this is we can start injecting commands into this SQL query to get data from the database that we might not otherwise have access to. And the way you usually do this is through a union command. What a union command does is, let's say you want to get data from two different tables. Because as you saw with the select command above, normally what you would do is you would say select star from employees. Okay, great. But then how do you get stuff from employees and products? Well, you'd use the union command for that. Union will let you run two select statements. But here's the trap for new players. All the select statements need to return the same number of rows. So if you are returning 3 rows from the original statement, your union statement needs to return 3 rows too. So if we do, let's select Sam and union select 1, see what happens. We get a 1 back. Okay, so Sam's not in the database, but we're able to return a 1. So we can return 1 value from this database. And so what we can do is we can union select SSN from employees where ID equals 3. Let's see if that works. We just do employee from, because I misspelled employees, that's why we're getting an error. Employees, actually we'll do ID equals 1 because I don't want to give the answer. This is Bill Gates' social security number that we're grabbing from the SQL command. So what was supposed to happen here is you were supposed to enter a name and it would tell you if that name exists. But because we were able to add extra commands after the name that you put in, we were able to construct this statement here, which also grabs the social security number of someone whose ID is 1. Awesome. So I hope that makes sense. So you have a template here where you put in a name, like name here. That becomes this command here. Select name from employees where name equals name here. This is what we put in. But because we can control all of this, here we can add another single quote, extend this statement out, and grab data from the database. And that is basic SQL injection. So there's some flags to find here. And then we will move on to SQL map, which is awesome. SQL map essentially does automated SQL injection. I'll show you how to do that really quickly. So you'll run this from the command line. 1.4.7 stable. SQL map.h, get the help. All right, awesome. So let's see, what are we doing for the example here? Map, I think there might be some more stuff I have to put in. Help, dash u, okay. So it's, do you want to check for under the database? So right now what it's doing is it's automating a SQL injection attack. Yeah, why not? And then over time, it's going to essentially allow us to dump the whole database or make changes to the database. And that's how you run it. So you basically run SQL map-h, look at all the options, and then you're going to run it against this URL right here. Let's see if it's done. U is vulnerable. Do you want to keep testing others? Nope, because we know U is vulnerable. There we go. Awesome. So then we'll do dump. There we go. Aha! Now we've just dumped the database using SQL map. So once again, this is what the command looks like. You have SQL map URL, you put in the URL, and then dump. I'll clear the screen because I think there might be some answers there. So just play around with SQL map. And then we'll do some blind SQL injection. Okay, so I like the idea of comparing blind SQL injection to a side channel attack. This was brought up the other day by another student. The idea is that a lot of times when you run SQL Query, you're not going to get data from the database directly back onto the screen. Sometimes you will get, for example, in this case, we're going to have the name that we put in reflected back. So it's not going to actually run data. We're not going to get a direct output from the database. So if we put in Bill Gates here, let's see what happens. Bill Gates. Check if Bill Gates is in the database. So it says user Bill Gates found. Okay, but what if we were to change that to X? There's no user X, so we don't get any result. However, what we can do is we can do some SQL injection here. So if we were to change this, so right now where name equals X, this is going to result to false. But let's make this true. So in order to make that true, we're going to say X or 1 equals 1, and then comment out the rest of the line. Aha. So what it did is it took our input and said, aha, that input is found. So this is what we mean by a blind SQL query. So we can't get data directly out of the database, but we can run SQL commands on the server regardless. We have to think about ways to get around this. And so what we can do is we can essentially we can play a game of 20 questions with the SQL server. So you can say, for example, does a user exist that starts with the letter A? Does a user exist that starts with the letter B? And so on. And normally what you would actually do is you would say, look at the results and say, does the result of this last bit have a 0 or a 1? And then you would get that data out. And you'd say, okay, how about the second to last bit? Is that a 0 or 1? And you would do that 8 times and you would get a byte out. And that's what we mean by blind SQL. So we can't directly see, but we can infer the answers to our queries. Let's go back. So you're going to use that to find social security numbers. You can find, for example, in this one, if we run this command here, we're going to select the name from the employees, rename equals Bill Gates, and substring 1 equals B. So we can test that the first letter is B in this name. Aha, it is. However, if let's say we wanted to check to see if the first letter in Bill Gates is a capital C, we're not going to get any output. So essentially we can ask yes or no questions to the server, and we can get yes or no answers. And we're going to use those yes or no answers to find some flags. And then I'll take a 2 or 3 minute break in case there are any questions, and then we'll move on to the next section.